Okay, now we're to the last part of our notes, which is where we take ratios and we put them together and create something beautiful called proportions. So what is a proportion? Well, if you look in your notes, a proportion is an equation that states that two ratios are equal. Remember when I was dividing up the M&Ms and I kept the ratio equal on purpose. Well, if in certain applications the ratio should be equal if the figures are similar or there is a proportional relationship. It is very important when working with ratios to label each of the values. So it's also important when working with proportions to label the values. One way I like to look at it, now we're usually dealing with four numbers when we have a proportion. With a ratio, we only had two. So I like to think of the given couple or the starting ratio that you have. So in the starting ratio, those are two numbers. They say there's this relationship between these two values, and they normally have different labels. For example, speed, you could be going 70 miles per hour. So that would be your starting ratio. I could ask the question, how far would you go in 3 hours? So that's getting more towards the final ratio and the proportion. So 3 is part of the final, and it goes with the hours on that label. And then we can say X, or any variable you want to use would stand for how far I'm going, and it would go with the miles label. So there are very different ways you can set up the proportions. You have a lot of freedom. Here I have the starting couple or the starting ratio going vertically on the left side, and I tend to have my answer couple on the right. But I don't want you to think that's the only way to set up a proportion. So as an example, let's say we have the 70 miles per 1 hour, and we have the X miles in 3 hours. So the squares stand for miles, those labels. You have the labels match across, and the hours are the circles. And the starting value are the red, and the final value is the purple. I can also write this ratio like it's rotated 90 degrees. So I could say 1 hour to 3 hours, 70 miles to X miles. I can do it even where I have the couples now switched. So I have the final couple on the left and the starting couple on the right, and it's all flipped. And then I can still, again, have the labels going vertically this time and the couples going horizontally. So here's my 70 miles in 1 hour, X miles in 3 hours. You can, and then coming back to what I started with, 70 miles, 1 hour, X miles, 3 hours. And you notice how I kind of tend to keep in that order. It's easier to think of that way. You can also flip it. I could say 1 hour, 70 miles, 3 hours, X miles. So you have a lot of freedom, again, to rearrange these. The main thing, you will always see how I have circles going vertically, and I have color going horizontally, so the couple. That is the main thing. You will never see this purple circle holding hands. We like to sometimes say they hold hands with the vertical and the horizontal. These two never come together. If they come together, that's an improper proportion. So now that I've shown you some of the ways to set up a proportion, what's a general way you can solve it? Well, I like to get, when we looked at fractions in 6th grade, and you said, okay, what's an equivalent fraction to 1/2? And you probably know that 2/4 is the same. How do you know that? Well, if you got a common denominator, you could compare them. And if the denominators are the same, then the numerators have to be the same. So my favorite way, or one of my favorite ways to solve a proportion, is to get a common denominator. So if this one's red, we'll say, and this one's purple, I'll pretend that's still the 1 hour, and that's the 3 hours. The common denominator would be 3, and I could get that by multiplying this by 1, which wouldn't do much, and I'd multiply this side by 3. So but if I do that to the bottom, I also have to do that to the top. So now that I have common denominators, remember we said once we have a common denominator on both sides, then the numerators have to be equal. And you end up with this. So you can actually ignore the denominators now. So you've probably seen jumping straight from a proportion to this, but what that comes from is getting a common denominator. So really, you called it cross multiplication. And this is a shortcut for getting a common denominator. You just say, oh, okay, yeah, I'm going to have to multiply both sides by purple, so you end up with that, or both top and bottom by purple and top and bottom by red here, and that's how you get that. This is many times a fast way to go ahead and move to, when you're solving a proportion, it's not always the fastest way. In fact, it's not usually the fastest way. So we'll see some examples. Example 1, I could cross multiply. I could say 20 equals 40 times x, but there's actually a much faster way to do this. I say, oh, look, if I multiply the bottom here by 2, then I'm going to have the common denominator. So you can basically say, aha, 1 equals 2x all over the 40. So 1 equals 2x means that x has to be a half. So in this problem, we had a scale model. Let me go back over the setup of the proportion. A scale model for a train is 1 to 40. So that's where the 1 on the model came from, and the 40 for the real engine came from. The real engine is 20 feet long. So the 20 feet has to go with the real. See how I have real engine matching across here, and I have models matching across here. 1 to 40 is my starting ratio, and x, my question mark, to 20 is my final ratio. Let's look at example 2a. Here we've already given you the proportion and we want to solve for x. You can actually do this without cross multiplying. You could say, oh, if I multiply times 2 here, then I know 3 times 2 will give me 6, so 4 times 2 has to give me x. So that's just a little reminder of how you might have done it in 6th grade. But we'll go ahead and get our common denominators. And you can see if I get 4x, I've got a 4 here and an x there, so 4 times x would give me a common denominator. So I multiply both sides, top and bottom here, by x over x and by 4 over 4. And then I get my common denominator, 4x, and you can see the top part looks like I had just cross multiplied, as if I'd gone 3 times x equals 4 times 6. And since the denominators are the same, then I can just say 3x equals 24. And hopefully you will figure out that means that x is 8. And our last example, I have 2 to x minus 3 is equal to 6 to x plus 5. This looks very intimidating, I know. First of all, write it in fractional notation with a fraction bar. So 2 over x minus 3 equals 6 over x plus 5. Now, you can cross multiply, which is fine, no problem. I'm going to go ahead and show the common denominators again to help reinforce where that cross multiplying comes from. And so I'm going to have this times that as my common denominator. So x plus 5 over x plus 5 on the left, x minus 3 over x minus 3 on the right. Then I'm going to use the distributive property to multiply this 2 times x plus 5. So if you're cross multiplying, you're at the same step right here. You just don't have the denominator. And so you would get 2 times x is 2 plus 2 times 5 is 10 equals 6 times x is 6x minus 6 times 3 is 18. So if you cross multiplied, you just had this top part. And then you can say, okay, now let me start solving it like an equation. Well, I have more x's on the right, so I'm going to take away 2 x's from both left and right. So I don't have any x's on the left. And that gives me 10 equals 4x minus 18. I want my x's and my regular numbers on opposite sides because I want x equals something. So I'm going to add 18 to undo that subtraction. So add 18 to both sides. And that gives me 28 equals 4x. Well, hopefully you'll figure out, oh, if 28 is 4x, then x needs to be 7. Now, how do you know if you are you doing your proportions properly? So here's a little checklist. Did you label all of the values correctly? So, you know, miles are with miles, hours are with hours. Do the labels match? So do the miles match with miles either horizontally or vertically? You can decide which way you want to go. Is the given couple either matching vertically or horizontally? So that was your starting ratio. Do the answer values match vertically or horizontally? And that would be your final ratios. Is it like this or like that? As long as they match. And so if you do all those things, if you match your labels, if you match your given values and the answer values, then you will be doing fine on your checklist.